Hey guys, Mike Builds, welcome back to the channel. This is going to be the part 2 series to our Calb battery build. In part 1, we built this battery on the bottom and you guys left me your thoughts and some of you guys seem to really like the build. And in this video, we're gonna go ahead and finish the build off by building this full pack. So we're gonna show all the work we did in this. We're gonna show a tiny bit less detail in wiring up the BMS. So if you need to know how to wire it, go watch part 1. I went into way more detail. Part 2 is just gonna be me just kind of showing you guys some of the highlights of this build. And then at the end of the video, we're gonna go over the price of this entire setup and how much I actually spent building this. So stick around if that's something you're interested in seeing. We're going to go ahead and assemble our second layer that's going to go over this layer. So we already have the box made. All the cells are down there. We have tons of wiring and everything I think we need to actually make this happen. I've actually had this battery in service now since we actually got the whole battery built, and it's been flawless. It's been working really well. My cat actually uses it as a cat rest area, so Dank really likes it. What's up, Dank? What you doing there, Dank? So he likes it. He chills up there. I did go ahead and source some metal so we can make metal legs to essentially put it on stilts. I also went ahead and 3D printed some terminal covers because I do not like the idea of the exposed terminals. That's why there's a towel up there. We're gonna throw these on all the terminals to insulate them and make them look a little bit neater. I also took all the DC wiring off of this side of the inverter cart and put everything on this side. I am printing some hold downs for the wiring. I also redid the cabling and stuff just to clean that up and make it a little bit nicer, and I'm a little bit more happy with it. What are you doing? On the battery itself, I did get a new negative cable made. I do have to insulate this part still. And then we also threw on this disconnect switch. I never ended up adding a fuse. I do still need to do that, and I would like to do that. From here, we have these 6-gauge wires that run up into here, and then it joins the rest of the system. Now, like I was saying before, in order to make the feet, I have some square tubing. Right here, this is really thick, nice square tubing. I do need to take the shortest piece and make all the pieces match that piece. And then what we're gonna do is we're gonna take those pieces and we're gonna pretty much do that. And we're gonna make a little foot out of flat bar in order to spread the weight, probably here on this corner and maybe a little bit right there. And we're gonna have a piece there on the other side, 2 in the middle and 2 on the ends. That way we can set our box on top of that, and I think that'll be plenty strong. So I'm gonna go ahead and get all our metal pieces prepped. Once we start kind of welding, I'll show you guys all that, and I'll set you up on the tripod so y'all can see that. So I got all our pieces evenly cut. I have the box out here upside down. So now what I'm gonna do is kind of mock up some flat bar. So pretty much something like this. I'm gonna cut this piece a little bit shorter, put the square tubing kind of right on the corner, and then we're gonna cut this. I'll probably put another piece right here, weld that as one piece, and then this will be welded to the flat bar, and then we'll drill some holes, put it through the box with some bolts. And then once all 6 legs are on it, we're actually gonna flip this over and go set it down on the inside battery and then make some feet on the bottom as well. And that's pretty much what the final product is going to look like. So I'm going to go ahead and get all these tacked up. I try to use my little speed square here to make sure I get these as square as possible. And that's it. That should be plenty strong to hold up these batteries. Also, my cat keeps trying to escape. I mean, it looks pretty flat to me. There's really no way to tell. So I think I'm just gonna send it. Ah, there we go. Perfectly square. All right, these are the center supports. I'm gonna put the bar in the middle on these. All right, these fit on here very nicely. They are still just tacked, but now I need to get my drill bit and go ahead and drill a hole. So every corner there, as well as the other 2, and then 2 small holes in the middle. That way we can put through bolts to bolt these basically to that top piece. Then we can go flip it over and put it on the other piece. And once we actually get the bolts through the top box, that way everything's kind of permanently mounted, we can actually go test fit it. All right, now we are gonna have to end up taking these back off in order to paint them, but just for now, we're gonna go ahead and get all the legs bolted on, because I don't actually know if it'll fit yet. You know, it might be too something, I don't know. All right, as far as the 2 center legs, I drilled a lot smaller holes, so these are probably more than likely just gonna get some small screws, kind of like that. But I'm not gonna put these on yet because I need to see where the forward one's gonna be because I don't want it to hit the BMS. It'll make more sense once this box is on the other box. All right, guys, here we go. First test fit of the top box. So I'm grabbing it from outside right now. All right. And even if I wasn't putting this on top, this would actually make a really good standalone box by itself with the legs. So I really do like that. I just don't know how much it would flex in the middle without the third support on either side. Hopefully the battery disconnect switch is in the way. I might have to move that over a little bit, but let's see here. Oh wow, it actually fits perfect. It is hitting the disconnect switch right here, but that's not a big deal. That actually might work out just fine. So on the bottom, I am gonna end up adding flat bar, just like I did on the top, just to kind of help distribute the weight a little bit. But that's what it looks like. And as you guys can see, it looks freaking awesome. Still tons of space on the back. I haven't put anything on the back. And then between here, I'd say there's probably about 3 inches between the top, which I think is plenty to get my hand here if I need to adjust or do anything, which we shouldn't have to. See, it's gonna kind of block the BMS, but maybe I can go there or move beans. I don't know, I can do something like that. That'll definitely work. I'm just more concerned with the box flexing with the additional weight of 200 pounds on it. And there's a gap there, so I'm gonna have to fill that anyways. Yeah, so it'll probably more than likely just go like this, and it kind of hides the wires right here. And this cable will just be out here like this. I guess that's fine. Or I could always run it behind it, but I don't mind it being right here, honestly. And then here's the one on the back. So that fits in there like so. But that's how it's gonna look. That's gonna be the final product more or less. I also do wanna build some sort of lid once we get the cells and the wiring and everything done. So we'll see about doing that. You guys will see at the end of the video what I come up with. Now I'm gonna go ahead and pull all the legs off. I'm gonna put those bottom tabs on, get the holes drilled. More than likely, to mount this on the bottom, because I can't easily put a bolt through here without having to drill through all this, I think I'm just gonna put a screw, because realistically the weight of the battery will just kind of hold itself to the bottom, and the screw will just be so it cannot shift around. I don't think I'll have an issue with that. This thing's more or less going to be stationary anyways. I don't plan on moving it a bunch. So I'm going to get those feet added and get those welded on. Then we're going to paint all the pieces, and then once the pieces are painted, we're going to get everything fully mounted to the cart, and I'll bring you guys back once we get all that done. All right, so we got all our feet pieces painted. They look pretty good. So we have the top box fully mounted on the bottom. We got all 6 supports on there, and that's it. It's very well secured. I don't think it's gonna go anywhere. Should be plenty of strength for this design. I think it's actually a little bit overkill, but this thing's pretty much good to go now. To hold it on the bottom, all I did was simply drill a small pilot hole and put a deck screw with a nut as a washer. So that'll just kind of keep the feet sitting on the wood. And I think the weight of the box will kind of push down on the bottom part anyway. So this thing should be very sturdy. I mean, just kind of moving it around like this, it feels like it's not really gonna go nowhere, so I think we're good there. Now I'm gonna go ahead and start prepping all the cells to get loaded in the box. I've already made our balance harness. I just have to finish soldering all our little eyelets on. I have our BMS right here. We're gonna go ahead and crimp on our copper lugs, get that guy all ready to go. I have all of our bus bars here. These need to get drilled out because the hole is too small for the bolts that we're using, which are M8 by 1.25. Got those guys right here, good to go. So I gotta get those drilled out. Once I have all that stuff done, we're gonna load this thing up and start wiring everything. I'm not gonna go in as much detail on how to wire this one as the last battery, just because I already did that. So if you guys need help wiring your BMS, and this is the first video you're watching, go check out the previous video and I'll show you guys exactly the step-by-step on how to wire the BMS. But this one, we're just gonna kind of blast through it. Don't need to re-go over all that again. I think I'm just gonna throw the cells in the box because I wanna move this thing around and see how good it feels just to roll it around on the cart. And I also wanna see if this is gonna sag or move at all. So let's get this thing loaded up with 16 of our Calb CA180 cells. What the heck? Oh, there's a little glue bump right here. Let me go ahead and sand that down real quick. All right, there we go. Got a little bit of a wood glue we had to clean off there. There we go, final cell. Boom. Oh, that fits perfect. Now I'm gonna tighten these end cap screws just like we did on the last battery to put a little bit of compression on this. Look at that, awesome, all loaded up. Let's try to roll this thing around now and make sure it rolls very smoothly. And I don't know if I showed this in the previous video, but for anyone's curious, these are rated at 375 pounds each, and we have 4 of them. So that's over 1,200 pounds of weight capacity. I believe total with 32 of these cells plus all the boxes and all that, we're probably right around 450, 500 pounds at the most. So we should be well within the rate limit of those casters. Yep, still moves around pretty easily. But yeah, it's really nice. I can really just grab this, move it where I want to move it, It's definitely heavy, don't get me wrong, but it seems to roll pretty smooth. Okay guys, big update on the battery's progress. So off camera, I did a lot of tidying up of the balance harness, as you guys can see, and it came out really nice. I think so. BMS is all mounted, all that's good to go. I'm currently making the negative terminal, so this is gonna come down off the battery and connect up here to the BMS. For anybody curious, I'm using 4-gauge Geely brand battery cable off Amazon. If you're going to buy any sort of battery cable off Amazon or anywhere, use pure copper or oxygen-free copper. Do not use copper-clad aluminum. I do not recommend that stuff. I'm gonna put links to everything in the description also, and I'm gonna do that on the other video as well. So all the parts you guys see me using in this video, I will put links to, just in case you guys wanna go check it out or you need some stuff for your own battery. But this was very time consuming. It doesn't look like much, but trust me guys, I've been at this for a few hours at this point. All of our terminals are torqued down. And then for some added safety, I have these 100 amp fuses I'm gonna put on the positive terminals of both batteries just to give this thing some extra safety and redundancy. I don't believe it's a bad thing to do. As long as all your connections are really good, if you're gonna add a bunch of stuff to your battery, make sure all your connections are secure and you will not have any issues. But I'm gonna get all the cables already made. Even though I don't have the switch yet, I'm just gonna make the positive link long enough to where when the switch gets here, I can mount that on there. I think I'm gonna end up switching the rear casters on this side to fixed wheels because when I move this thing around, the casters tend to weeble wobble and do all kinds of crazy stuff. So I think I'm gonna switch those to straights. I think that's gonna make moving this thing around a little bit easier. Although once it's in its permanent spot, which is more than likely gonna be against the window, we're not gonna be moving it a ton anyways, but I do plan on redoing my whole setup here in the future pretty soon anyways to be able to move all the batteries around and really make this look like a professional setup and not like a hoarder's home like it looks like right now. I did end up printing more terminal covers, so we're gonna go ahead and throw terminal covers over everything after I verify torque one more time to make sure we don't have any loose connections. But I'm gonna go ahead and get the main leads done. Once those are done, we're gonna actually power up the BMS, verify all the cells are good to go, and kind of go from there. All right, battery boys, I have the switch connected to our BMS, so I'm gonna go ahead and kick this on. Okay, it kicked on. Now I'm gonna open the BMS app on my phone. So there's the BMS we have currently hooked up for the bottom battery. This is gonna be the new one on the bottom. And there we go, everything is working well. I have one cell that's a little bit low. I think I actually mixed the cells up because I originally had some of the cells charged, but that's not a big deal. The balance function should take care of that. I'm gonna go ahead and put all the settings I wanna run into the app right now and set it to Lifepo mode. And there we go, everything is set, good to go. I run this thing at these settings for anyone curious. I normally just leave the Lifepo4 settings default to what the BMS wants. So all the cell over voltage, under voltage, and all that stuff, I normally just leave that alone, but you can go in there and change all that for your personal preferences. But yeah, this thing's good to go. We have no warning messages, so we're just gonna let the battery balance and let it do its thing while we finish up everything else. I don't know, this fuse is kind of tall. I might have to put this. Look at these nice homemade crimps. That is awesome. I have a video on how to do these, by the way, guys, if you want to know how to make crimps just like this. Where's that croissant wrench? There we go, nice and secure. This cap doesn't seem to fit on anything, so that's fine, I guess. I'm also 3D printing some more wire hold down, so I have those printing right now. We're going to put those on the battery to hold all the cables nice and neat. So I think right now, just for this cable, since I don't have the switch, I'm gonna cut it probably right about here, and that'll be the cable number 1. We'll have another cable coming out of the switch to the set of bus bars, and then from there, we'll be able to hook up the other battery to the bus bars with some jumper cables, or a set of jumper leads. It's been a few days since the last clip you guys just saw. I actually have put the battery in service just to kind of help balance the battery and actually get it running and get it charged up. I will say the active balancer that's on the JK BMSs is amazing because this cell is almost fully balanced to the rest. I also got some more parts in the mail so we can go ahead and finish the install completely. So we got another set of these bus bars right here. I really like using these smaller ones just for things like this. We got our battery disconnect switch. I've been running this cheap one on some of my other builds for a really long time, and it seems to work really good. I want to do a torture test video on these in the future where I take another one and actually run like 200 amps through it. And then I want to use a thermal camera to see if it actually generates any heat, because that's kind of my concern using these cheap ones, is if it creates a resistance or not. And it also came with all the hardware. So we're gonna get all this stuff installed on the battery, hopefully get all the wiring done. We also need to put the terminal covers on, so we're gonna do that as well. And that's it, I'm gonna set you guys up on the tripod. We're gonna get all that knocked out. In order to mount our switch and our bus bars to the side of the battery, on this one, I just screwed them directly to the wood. But my fear is if the screw is too long and it goes through the wood too far, it's gonna actually hit the cell. So for the top battery, we're actually gonna put everything on this little wooden plate, and that's where we're gonna mount the switch and the bus bars. And then I'll be really careful in putting just only 2 screws, or maybe even hot glue this or Velcro it to the side of this battery. That way there's way less of a chance of us going through this and hitting the cells, because that's a real danger and we don't want to do that. Go guys, just like that, nice and simple. The screws I'm gonna be using to screw this into the box, as y'all can see, they only protrude a little bit, so that will not have any risk of actually puncturing the wood all the way through and hitting the cells. Actually, I'm gonna go ahead and power down the BMS, that way this thing isn't live. That's so nice, having a switch. Okay, problem number 1, this lug is too small, so I'm either gonna have to drill this out or make another cable and put a bigger lug. So I'm probably gonna end up doing that because I don't have a big enough drill bit right now. All right guys, there we go. We got our little connection set up all done and good to go. And then we're gonna make 2 more cables to go from these bus bars to our bottom ones to connect the batteries together, and that's it. That's all gonna be done. All the wiring is gonna be done. Pretty much got all this stuff done, nice and clean, came out really good. We got our battery disconnect switch. We got our fuse on there with the cap that for some reason doesn't fit. I also 3D printed some hold downs that we're gonna be able to hot glue to the box in order to zip tie the wire down, but right now it just kind of hugs the corner, and that came out really good. We need to insulate that. This all came out really good. It looks really clean. I think it's gonna work very well. Got our leads coming down to parallel the 2 batteries together, and that's it. Now what I'm gonna do is I'm gonna go ahead and put our covers on that we 3D printed to cover the terminals up to make this all safe. Now when these are printed, they actually have a slot right here for the balance wire to come out of. But because we did sideways balance wires like that, this isn't really gonna fit that good. And on the bottom battery, that's kind of the result. So it doesn't look super clean. On the bottom, it doesn't really matter because nothing's gonna get in here and short these out, and it's still somewhat safe. But on the top, I wanna make it look a lot cleaner because you're gonna be able to see this at least until I get the cover built. So what I'm gonna do is I'm gonna cut a little groove right here. That way when this goes over it, the wire will sit in there nice and flush. So I'm gonna go ahead and get all those marked and get those grooves made, and then we're gonna zip tie those all on. All right, so there's our mark. And I have a little burning tool, and we're just gonna burn the little groove that we need. Not burning myself, hopefully. Focus, there we go. Oh yeah, that stinks. And then we take our cap, bam, look at that. Fits perfect, sits on there nice and flush, and then all we gotta do is throw our zip tie around. So I'm gonna get all the other ones modified, then we'll slap them on. Dang, guys, look how good this looks. Oop, I'm casting a shadow. Look at this. The bus bars are now covered, nice and safe. Toward the end there, I tried to aim the zip ties kind of in so it looks a little bit cleaner. That looks really good. I'm gonna go try to find a 3D printable file to make one little cap for this and for this one as well. We got our negative wire all attached, looking nice. Still gotta insulate that. Same on the bottom. Okay guys, we're very, very near the end of building this battery. We're pretty much almost done with it. There's a few more small things we still need to do. Hey man, leave those alone. So if you guys saw in the last video, we put 4 casters on this thing that swivel, and I think I'm gonna change one set of casters to just a set of straight casters that don't swivel. I'm also gonna build an output cable consisting of this 4-gauge wire and an Anderson connector. That's gonna go in our main outputs right here, and I'm gonna be able to plug that into the rest of the 48-volt setup. Right now, I just have a set of 6-gauge wires that I was temporarily running to it, and that worked just fine, but I wanna have an Anderson connector so we can easily unplug everything. That's how I have the rest of my batteries set up. My server rack batteries have one, and my eco-worthy batteries also have one, and these work just fine. And that's it. So we're gonna go ahead and get both of those made, get the wheel swapped on. Once we're done, I'm gonna do a whole parts breakdown and cost breakdown of this whole setup for you guys who wanna know exactly what this costs and all the parts we used, and we'll kind of wrap this up. This thing is pretty much done at this stage. The last thing I did go ahead and do is make a new cable, and that's also made out of 4-gauge wire. Goes to this big Anderson plug, and that ties into the rest of the 48-volt system with these bus bars right here. So now this battery is in parallel with the rest, with the server rack batteries and with the eco-worthy batteries. And yeah, guys, this thing turned out pretty awesome. This is probably the biggest battery build I've ever done, and I've done quite a few on this channel. And this thing came out really well. Now that we got both batteries completely done, completely built, this thing is 100% operational in service. This is 18 kilowatt hours total of capacity, bunch of capacity. Now I'm gonna actually break down the cost on what this cost me to build. Now keep in mind, this does not include the time I put into this. And it's kind of hard to quantify that because I just kind of worked on this, you know, an hour or two each night for probably the last 2 weeks, honestly. It's been a lot of work, a lot more work than it seems on camera, just because I kind of skipped through a lot of the tedious stuff, and I just really tried to show you guys the main points of the build. So I have a cost list. I'm gonna go over everything itemized, and we're gonna give you guys the grand total at the end. So what do you guys think it's gonna be? Let's get into it. All right, first off is the Calb CA180 cells. I actually got a really good deal on these cells on Facebook Market. They were $35 each, and that gives me a grand total of 1,120 bucks for 32 cells. That tends to be the bulk of the price when you build something like this. Next, we have the JK BMSs. We have 2 of these. Each of these I got on Amazon for 130 bucks delivered. So we're at 260 for 2 BMSs. And in my opinion, for the money, these are probably some of the better BMSs you can get. They have tons of features, as you guys saw. All right, next we have the actual battery bus bars. They actually came free with the cell, so I put free for those, but if you had to buy those, I would have to guess I would add an additional $100 maybe, depending on how expensive of a bus bar you get, but 100 bucks is probably overshooting what you'd actually spend, but those are free in this build. The stainless steel bolts that actually go on the cells, the M8 by 1.25 by 16 millimeter bolts, I spent $30 on all of those. The main terminal fuse here and the one on the bottom battery, those were $28 for 2 of those, but I went ahead and rounded up to 30. Our wire bus bars, which are these and these, were 35 bucks for 2 sets. 2 different sets. The battery switches for 2 of these was $20. The casters from Harbor Freight were $75 for 4 casters. These are rated at 375 pounds each. The wood is all plywood. It's like 1630 seconds or 1730 seconds, some weird size. And for a sheet of this stuff was about 35 bucks from Home Depot. Metal tubing is 14 gauge, 1-inch square tubing on the bottom and 11 gauge, 1.5-inch square tubing on the top. I put 30 bucks for square tubing because if you buy this at a metal supply store, it's about $1, $1.50 per foot. So you can get a 20-foot stick of this stuff for about 30 bucks. All the wire we use, this is all 4-gauge wire off Amazon. This is really nice, high quality copper wire, not copper clad aluminum, cheap stuff. And it was 80 bucks for all the wire that we use, and I still have a little bit of wire left. So that could actually go toward other projects. So I tried to round up a little bit. The total cost on this, not including labor, is about $1,715. So at $1,715, we're right about $95 per kilowatt hour, which is very good for a battery of this scale and this power. This battery can easily output 180 amps continuous, and these cells are actually rated to do 360 amp burst, but we're never gonna get that much out of it. I'm never gonna need that much out of it, so it's a little bit overkill. Calb cells are really great. I think the one downside is they're not very volumetrically efficient. When I say that, I mean for the size of the cell, you can get more energy dense cells for about the same size. That's kind of the only drawback to using Calb cells, but the good thing is because they're plastic, we can put them right up against each other. We don't got to put any insulation material around it, and they are very safe. In theory, I expect to get about 10 years of use out of this battery, maybe even more. These cells are rated between 2,000 to 4,000 cycles if you discharge them to 100%, back up to 100, down to 0, back up to 100. I never plan on doing that. These are gonna get very shallowly cycled. But that's really gonna do it, guys. Let me know you guys' thoughts on the battery build. Let me know what else I could incorporate to make this better in y'all's opinions, and let me know what kind of batteries you guys are working on or building. And if you had a battery this size, what would you use it for? Would this be enough for your setup? Would you want multiple of these? Would this be overkill? So now that I have this battery in service with the rest of my 48-volt equipment, we are at about 42 kilowatt hours of storage capacity, which is awesome. My house never uses that much. This is not connected to my house currently, but in the future, I want to upgrade the inverter. I think I've said that in some of my other videos. Whenever tariffs kind of chill out, if they ever do, and the inverters come down in price a little bit, I do want to upgrade my inverter to a bigger one that we can actually potentially run the house on. But until that happens, at least we have plenty of battery storage. In fact, I can't fit any more battery storage, otherwise my house would just be completely ruined more than it already is. Honestly, this thing was a joy to build. It was a lot of work. If you're going to build your own packs, there is a lot of small things you need to do besides put the battery cells in a holder. So just kind of keep that in mind if you're gonna build your own pack. They do have the big DIY battery boxes you can buy, and all you have to do is add your cells to those. And those are awesome, but they also are a little bit expensive. I think as far as DIY battery pack goes, this is pretty much, in my opinion, about as good as it gets as far as price. Let me know what you guys think in the comments. Share your thoughts. Thank you all so much for watching, and I'll see you guys later.